This presentation is about conceptual modeling. The question to answer in this presentation is: what is a concept? What is a conceptual model? Why do we create conceptual models? And what is classification and generalization? I start with these pictures showing the real world on one side and the model or the modeling world on the other side. Concepts are used in the real world. People are speaking to each other, people are exchanging documents, they are reading and writing documents. But also the systems are using concepts. Both the concepts in the business world and in the system world could be represented as conceptual models. Sometimes the conceptual models representing a concept in the business world is called domain models, while the conceptual models representing a concept in the system world is called system models. We start with the concepts in the real world. A concept is how we think about things, or what we mean. A concept can be seen as a thought unit or a mental view, the picture you get in your head when you think about things. A term is a representation of that concept. It could be seen as a sign for the concept, some kind of identification for the concept. For example, in form of a word, a group of words, sometimes called phrase, or a symbol. In order to express a concept, a term is needed. If you want to express your thoughts, you need to use terms. If the relationship between the term and the concept is ambiguous, interpretation problem can emerge. People can have problem communicating with each other. The existence of synonyms, polysems and homonyms can cause such interpretation problem. A synonym is a term that means the same as another term in the same language. For example, buy and purchase are synonyms, at least in most of the context. The same thing with big and large. Two terms means the same thing. Polysems and homonyms. Polysems is a term that have different but related meanings. An example is democracy. When I was young, there existed the Soviet version of democracy and the US version of democracy. That means they use the same term with a positive, that has a positive meaning, but actually the democracy in US have a different meanings than the democracy in the Soviet Republic. The same thing with service-oriented development that was very popular, has been very popular among companies. Many companies claim that they are service-oriented and that they are carrying out service-oriented development, even though they mean different things with service-oriented development. Homonym is two terms that have the same spelling or sound and have different meanings. The difference between polysem and homonyms is usually very hard to grasp, and a lot of people are discussing the differences. But to make it simple, homonym is two terms, while polysem is one term, and in polysem that term have different meanings, can have different meanings in different contexts. Extension is the things to which the concept correspond, such as physical thing. It should be seen as the real world out there. Intention, on the other hand, is the meaning of the terms, and it's very close or synonym to concept. A definition is a way to specify what you actually mean. It's a statement of the meaning of a term, and you use definitions to limit possible interpretation of that term. Definition could be extensional or intentional. We start with intentional definitions. These specify the characteristic of the concept that a term represents. For example, a bachelor is a man that is unmarried, or a computer is a general purpose device that can be programmed to carry out a set of arithmetic or logical operations automatically. The idea with an intentional definition is to grasp the characteristic of the concept, of the idea. Extensional definition, on the other hand, lists things in the extension that falls under the definition. For example, if the term to define is computer, you need to list all the computers. Or if the term is bachelor, you need to list all the unmarried men in the world. Here I provide you with some guidelines for definition. You should use intentional definitions and not extensional if possible. You should start the intentional definition by using the expression bachelor is or bachelor means, and then define what you mean by it. And you should use the genus differentia method when you define a term. The genus differentia method is described in this slide here, but I start with an example. An example of a definition is a witness. A witness is a term that you want to define, is a person that testified under oath at a trial. So first in the definition here you can find the category to which the witness belongs, which is a person. And then you also specify what differs the witness from other persons, namely that the witness testified under oath at a trial. So the genus differentia method specify that you should first specify the category to which the item is supposed to belong to. In this case, it was the person. And then in the next part, you should also specify what is characteristic for that item compared to other items in the same category. This context term extension figure that I used is similar to what's sometimes called the semiotic or the semantic triangle. There are many different semiotic and semantic triangle out there on internet or in different books. And I here actually give some examples of synonym to the word I used, concept, extension, and term. You can see them here. I now want to introduce a standard called SBVR, which is a standard defining things that we have talked about, such as concept, terms, definition, things, expressions, and so on. SBVR also present a semiotic and semantic triangle, and you see it here. You recognize that we have the extension on the right side, we have the meaning in the top, but then you can see that they make a difference between representation and expression here. In the previous slide, we don't make this difference between expression and representation. And the expression is actually a sequence of characters. It's a set of characters following each other. while the representation is the term. For example, this could help you to make a difference between homonym and polysems that we discussed before. We said that a homonym is two different terms with two different meanings, but they have the same expression, the same character sequence. While the polysems is one term that can have different meanings. So this difference between meaning, representation, and expression can actually help you better understand the difference between homonyms and polysem. And another interesting thing here is that SBVR claimed that definition is a representation of the meaning. When we discussed definition, and especially intentional definition, we actually connected it more up to the meaning, to the concept in this triangle. Let us now check what SBVR mean by expression, representation, meaning, and extension. This table is from their standard, from the specification that you can download. The concept that we want to discuss here is driver, how we think about drivers, what characterize them. You can see that in the column meaning. The extension, what exists in the real world, are the actual drivers of motor vehicles. The expression here, to the right in the table, is the character sequence driver, the set of letters following each other. And the representation is the term which relate the concept with the character sequence. And as I mentioned before, also the definition is a representation. And again, that definition expression is a character sequence, a set of characters. SBVR is an abbreviation for Semantic of Business Vocabulary and Rules. It's the OMG specification, and it supports documentation of semantics of business vocabularies and business rules. That means that SBVR also support exchange between such business vocabularies and business rules in different organization and IT system. I will continue introducing some concepts that from SBVR because I think they are very good to understand what we do when we create conceptual model. SBVR introduced 4 concepts: individual concept, general concept, verb concept, and individual fact. And I actually been inspired by an author called Harst in his book SBVR Made Easy, which is a very nice book to read, and it tried to explain SBVR in an easy way. We start with individual concept. An individual concept corresponds to one specific thing, that is one instance in the extension in the real world. So in this example you can see Anna Swan exists in the real world, and the individual and she is the individual concept, so to say. General concept, on the other hand, correspond to 2 or more actual things that are grouped. That is, it corresponds to a group of instances in the extension. So in this example here, you can see that Elsa Falk and Gunnar Trana are grouped together. There are 2 instances that are grouped together, and you sort of say classify these as student. So this procedure, when you group instances and create a general concept could be called classification. The two first concepts that we discussed, individual concept and general concept, were focused on nouns. Now we go to the verbs. Because things get involved in relationship with other things. And you can see a verb concept as the whole structure of the relationships and the general concept that are related. Look at the figure here in the bottom in the extension. We had a group of people that registered for a group of courses. So we have a group, a class called student registered for course. And this whole structure with the two general concept and the relationship expressed as a verb phrase is called a verb concept. So the verb is not just the verb, it's also the two general concept, the two nouns connected via this verb. Finally, we have the individual fact. Again, look down in the extension, you can see that Anna Svan, which is an instance, is registered for one course, the subcom course, which is an instance. So individual facts is the whole structure of a relationship and the related individual concept, and not general concept in this case. And individual facts is something that may be found to occur in the extensions or not. It could be actual or not actual, true or false. It could be false or true that Anna Svan is registered for the subcom course. Let's now go to the conceptual model and discuss what we do when we create conceptual models. Well, one way to describe that is to think about the instances in the real world, and you can model them. For example, we can model Elsa Falk and we can model Gunnar Trana. So we're modeling instances in this case. But usually when you're modeling conceptual model, you don't model instances. You model group of instances. You model classes. So in this case, here in the bottom you can see Elsa Falk and Gunnar Trana, and we group them and create a class called student. And this procedure, when you group instances in the real world, is called classification. Classification in practice means that properties that are common between the instances are highlighted, and properties that differ between them are disregarded. So in this case, we're focusing on that both these are students, and we, for example, disregard that they are different genders, and so on and so on and so on. We have now created a class by using the procedure classification. Now we can give this class properties or characteristic or attributes. We are going to use the term attributes because this is a term that UML use. And these attributes, so to say, is the common characteristic of these of this class here. Okay, now we created a class, and this class could be seen as a template for creating model instances, often called objects. And this procedure is called instantiation. We have the class, it works as a template, and based on that template we can create, in this case we have created two objects. And when we do that, we actually give values to the attributes, as you can see here. Let's now summarize what we have said so far. We have instances in the real world, we group them, mean that we classify them into a class. In this case, the class is student. And we give the student attributes, which is the characteristic, the common characteristic of the instances. And when we have created this class, we can also now instantiate objects of this class. And when we do that, we provide each object with values. Note that when we do conceptual model, we often don't model the objects. We actually focus on modeling classes and the relationship between classes. Relationship between classes means that you model the two classes and you show the relation, in this case with a line. And in this way you create a diagram and model. And you can compare this actually to the SBVR verb concept that we discussed before. Relationships between classes are called associations in UML. And this diagram or model that you see in front of you can be seen as a class and association structure. Here you can see that UML called the classes for class and the relationship between the classes for association. This class and association structure can be seen as an information structure, actually constraining what objects and links that are possible to instantiate based on this information structure. Try to be a little bit more concrete. You have this class and association structure, and that could be the base for creating objects and link structures. So, for example, under the class and association structure, we can see the first object and link structure, Elsa Falk, registered for the subcom, and the second, Gunnar Trana, registered for the subcom course as well. You can see that they register to the same object, the subcom course. Interesting here is that the objects, so to say, is objects of the classes, but note here that the association between the objects are called links in UML. And links are, so to say, the objects of the association in the class and association structure. So also the association is a kind of a classification of links between objects. These objects and link structures, which actually can compare to SBVR's individual facts, are usually not modeled when you do conceptual model, but you could model them in some sometimes in some reasons. So a relationship between two objects is called a link in UML. Let's now go to classification and generalization and try to explain what that is. Classification we have met before. Classification is grouping of instances. In the picture here, you can see that we grouped Anna Svan and Elsa Falk and classified them as women. And we also grouped Elsa Falk and Gunnar Trana and created the class student. Generalization, on the other hand, are actually grouping of classes where one class totally includes another. The opposite of generalization is specialization. Let's check the model in front of you. You can see that the class woman is totally included in the class person. And in the same way, the class student is totally included in the class person. That means that person is a generalization of woman, but person is also a generalization of student. And since the opposite to generalization is specialization, woman and student are specializations of person. You can test if a relationship between two classes is a generalization specialization relationship by asking if all instances of the specialized class are included in the more general class. For example, are all the instances of the class woman also included or part of the class person? In this case, the answer is yes. All instances of woman are also instances of person. And it's in the same way, all instances of student, Elsa Falk and Gunnar Trana, are also instances of the class person. So both woman and student are specializations of the more general class person. A more tricky question is woman a generalization of student? Well, the test was, are all instances of student included in the class woman? And you can see that Gunnar Trana is not included in the class woman. So no, woman is not a generalization of student, meaning student is not a specialization of woman. In UML, you model generalization and specialization in the following way. Use a certain type of array, as you can see here. We have the person class, which is sometimes called superclass, and then we have the more specialized classes, which are sometimes called subclasses. In the end here, we want to describe why we do conceptual modeling. Well, one reason for that is to specify the terms and concepts that are used in the organization or should be used in the organization. In the latter case, maybe you want to develop a common vocabulary to support communication in the organization. You can also use conceptual modeling when you want to develop an information system. So you should specify the terms and concepts and also make sure that these are the same terms and concepts that the people are using in the organization. And thereby you're supporting what is called business IT alignment. You get an alignment between business and IT, which makes the business very much more effective if it's not the case that business and IT are aligned. So it will be much easier for people to work in an information system if the information system uses the same term and concept that are used in the organization. Conceptual model could also be used as a first step to develop a database system or a Java program. So they provide the information structure of the database or the Java program. And today, these conceptual models could also be used to generate part of the database schema or the Java code by using what is called model-driven development tools. So some groups of software developers actually use these kind of tools and start designing the system by creating a conceptual model. Put that conceptual model in the tool and let the tool, so to say, generate the skeleton of the Java program or the database schema. And then you usually have to go in manually to make some changes. Conceptual modeling could also be used to support integration between department, organization, and information system. You can use you can, so to say, create the conceptual model of how people speak for each department. You can create a conceptual model to show the differences, how people are using terms and concepts, and then you can start mapping the terms and concepts and see which, for example, in one department, one term has the same meaning as another term in another department, and in this way you can, so to say, understand how you better can integrate the department by, for example, creating a common vocabulary. Now we are back to the questions that we started with. What is a concept? What is a conceptual model? Why do we create conceptual model? And finally, what is classification and generalization?